All right, you are taking your Unit 2 test Part 1 next week, and the study materials are in Schoology. They're not in any particular folder because I want you to be able to find them easily, and they're right there. So just like the other one, the other unit test that we did, the puzzle piece study guide helps you with the part that you take on Eliminate. So that's usually anywhere from like 10 to 12 questions. And then that part is worth 100 points. Like when you test for it, it's worth 100 assessment points. And then this study guide is going to be worth 100 class points. So that it like mirrors it so that I make sure that you do it and that you try to get a good score on it. The score that you get on it usually can tell you what you'll score on the real thing, granted, as long as you're not like cheating or anything. It's reflected to look just like the real test. All the skills on there are just like the real test. So make sure you know how to do that. And if you don't, make sure that you ask questions. And then this, I still need to get printed out, but if you want to look at it in advance, this will be worth 50 class points because it's going to be the study guide for the constructed response part. Because remember, you take 2 parts in 1 hour. All right. And that goes in as an assessment grade, but the study guide goes in as classwork. Worth more than like your normal 10-point homework assignment. But I will be passing it out on, I think Monday actually is when I'll pass it out. But if you want to work on it ahead, you're welcome to do it on your own paper. This is what your constructed response will look like, just different numbers, different situation. I told you you would have to graph by hand, so you could start practicing. So that's all there. I'll give you time to work on it next week, but I want you to have it as soon as I have it ready, so that way you can start preparing. Today and tomorrow is the last day of instruction. Next week, we're just reviewing and testing. So there's that. All right, you do have a warm up on your paper. We have 2 systems here. First, determine could it be solved by elimination? And then if not, could it be solved by graphing? And then if so, solve it by graphing. So you all need to have graphing technology out, whether it's on your Chromebook, or you're using Desmos on your phone would be fine too, as long as it's on Desmos and not other apps.
I expect you back.
But follow the instructions on this. It's not printed on your paper. If you need somewhere to write it, there's plenty of room on the back of your paper, but only on this question. Okay. So based on what I've taught you so far, could this be solved by elimination? And why not? Okay, and the thing, what's the proper name for that thing? Not variable. They do have variables that are the same. Well, these are technically considered like terms, but like that word, what's the vocab word? We want to look for this to be in common in order to do elimination. A common. No, the variable is common. Well, yes, it would have the same solution for both, but there's like a word that you guys are just missing. So Parker's right, but he said things, and I want to know what that thing is that needs to be alike. So why can't I solve this by elimination based on what I've taught you so far? What things have to be common? All right, well, while you guys try to tell me what that word is, so based on what I've taught you so far, you can't. But the real answer is yes, it can be, and you're gonna learn that way today. Did you find it?
Coefficient.
Coefficient. So coefficient's the number in front of the variable. If I want to solve it by elimination, I would need like either this X to have a 4 or a -4 in front of it, or this Y to have a 2 or a -2 in front of it. Like, we want the numbers to be the same. They could be opposite symbols, but they need to be common coefficients for it to be solvable by elimination. And today I'll show you how to do that when it's not already like that. Okay, so technically, yes, it can be. You just might not know how to do it yet. You might have learned it in a previous year. Now, it definitely can be solved by graphing. What is the solution when you solved it by graphing, Josiah? Okay, now I actually didn't do it myself yet, so is that correct? Okay, so yeah, graph both of them, see where they intersect. That XY coordinate that they intersect at is your solution. Now, here's what we're gonna do. At your table, most of you have about 3 people. If not, adjust it. But, and then some of you have 4. Whoever's sitting closest to where I'm at right now, what I want you to do is write an equation equivalent to equation A by multiplying both sides of it by the same number. So if you're sitting closest to where I'm at right now, you're gonna multiply it by 2. To the left of that person, you're gonna multiply by -5. To the left of that person, you'll multiply by 1/2. And then if you have a 4th person, pick a number. Could be one of these numbers, it could be a random number. But you're gonna multiply equation A on both sides by whatever number you were assigned. Questions on that? So you're making a 3rd equation by multiplying each side by the same number, and then maybe jot down your equation. You're gonna graph it also. Okay, so do that. Okay, so raise your hand if you were tasked to multiply it by 2. Okay, so hopefully you did it right. Let's kind of see. What you're doing is multiplying all the terms by the same value. I'm allowed to do that because that's what property of equality. When I multiply on both sides of the equal sign. So my question is, what property of equality is it when I multiply on both sides of the equal sign? Multiplication property of equality, right? When you would divide on each side, that's a division property of equality. When I multiply on each side, that's a multiplication property of equality. But yeah, essentially I put parentheses around equation A, and I am going to distribute that to everything. Normally you would just do it like on one side for distributing, but I'm doing it to all of them to keep it equal. So what's 2 times 4x? 2 times y, and 2 times 1. And when you graph that, those of you that had to multiply by 2, what did you notice on your graph? If you didn't graph it now. You have the right equation. You should have these 3 things on your graph. The 2 from the system, and now this one in red. So what are we noticing? It's negative. Okay, has a negative slope. Anything else we're noticing? Okay, maybe we'll get to the noticing in a little bit. But then other people had to multiply by a -5. All right, so they had to multiply all the terms by -5 in order to have done it right. So it's -5 times 4x, -5 times y, and -5 times 1. And then we had another person multiply by 1/2. On your tests, I'm telling you right now, you will have to distribute a fraction. That shouldn't be a question that you skip. Like, you can use Desmos to multiply fractions if you don't like it. Multiplying by 1/2 is usually pretty easy though, because what's half of 4? 2. So like 1/2 times 4x is Good. I don't know. The internet's not being my friend right now. Hang on. And then what's 1/2 times y? 1/2 y. Good. And what's 1/2 times 1?
0.5.
Good. I'm gonna put up as 1/2, but still, yeah, 0.5 is the same as 1/2. All right, now everyone, if you haven't already, and I know like if you had a fourth person, you probably picked a number. I don't think we have time to go over all the numbers you might have picked, but you should still notice the same thing when you graph all three equations. So you should be graphing your original system and then whatever third equation we created. So do that right now. Tell your group what you are noticing when you do that. You all should be noticing the same thing. And I'll freeze my screen. So what did we observe when we graphed all three equations? Haley? So all the three lines do? So I think you're on the right track. I just think you need to revise your observation a little bit. Only 2 of the lines have the same slope and y-intercept. Because what you should have graphed, maybe you're talking about you graphed these 3 colored equations. You should have graphed your original system plus whatever third equation you got from multiplying. Does that make sense? But yeah, all of these that we created have the same slope and y-intercept, so that is true. And why is it that there's 3 equations, but I only see 2 lines? What happened? Where's my red line? The red line has infinite solutions with which one? The green one. And the red equation is the one that I multiplied by a number. That's all. That's what you guys should be noticing as well. All right. So by multiplying on each side, I'm not changing the slope or y-intercept. It's still going to be the same line. But what that does, and maybe not with every single random one that you decided to multiply, but at least with this one, if I take this equation and I line it up with this bottom one, don't I have a common coefficient now? I do. And now I can actually solve by elimination, because now I would just subtract equation B and my third equation, and that would eliminate the y. Does that make sense? Okay, so it still works. This new method that I'm going to teach you still works. And now you could use elimination for any situation. Granted, there will still be some where you might choose another method because it would be easier, but you can do elimination. You might just have to multiply one or both of the equations by something to make it work. All right, so good. We are now going to do a card sort activity, so I need to give that to you. But, well, maybe this is before that. So anyway, this is the system that we were given, our original system. And this is the system that Elena wrote. What did she do to one or both of the equations to get that? You'll talk about that next with your group. And then look what she did after that. So in your group, discuss what were Elena's first 2 moves and what might be possible reasons for those moves that allow her to do that. And then continue solving this system. If you need to do scratch work, you could use the backside. But yeah. Now talk about that with your groups. What were her 2 moves? And why is she allowed to do that? All right. Table 6. Can you tell me what Elena's first move was? By what? And how do you know she multiplied it by 4?
4x.
So when you do the work yourself to prove that that's what she did, that's what you would have gotten as well, right? So that's how you can confirm that's what she did. What allows her to do that? What property? Multiplication. Property of equality. You could do whatever you want, as long as you do it to both sides of the equal sign. It'll still be equal, it'll still have the same solution. So that's why multiplying this one by 4, it would still give me the same line as equation B when I graphed it. That's what she did, and that's what allowed her to do it. Table 7, can you tell me what her next move was? So over here. Good. So she started to do elimination. All right, she subtracted to eliminate which variable? Good. In the earlier situation where I told you, like, I lined up one of the equations that you guys did, and we could have eliminated the y, because the common coefficient would be on the y, that's allowed to be done. All right, it would still give you the same final answer, but she chose to eliminate the x, and that's totally fine. She's allowed to do that. So then, yeah, 4x minus 4x is 0. That's why there's no x term here. Y minus 8y is negative 7y. 1 minus 36, negative 35y. So then what's my value for y going to be? 5. Because then next she would have had to divide each side by -7. And that's how she gets that y is 5. Would she be done at this point? What would she have to do next? She would need to now substitute the y into one of the original equations and solve for x. Which one do you think would be easier for her to plug into? Okay, and that's completely up to you. In elimination, you're allowed to plug into either one. So when I do that, that's what we get. Isolate the x. Opposite of adding 5 would be to do that on both sides. I get 4x equal to what's 1 minus 5? Opposite of multiplying by 4 would be 2. And then x ends up equaling what? And that's what it said here that it would equal if you looked ahead. But that's how you solve it algebraically. Questions on that process? All right, so I passed out a card sort to each group. What you're going to do is look at steps at how someone solved by elimination. So on your test, this is prepping you for your test. You will have a problem given to you, and even though that might not be the way that you choose to solve it, you still have to figure out what the correct steps would be. So this is a good preparation for that. You can use the front of your paper as kind of like a guide, because that's where you'll be putting the order of the cards when you know that they're right. So start with the one that says start here, and then figure out what order they should go in so that you get to your final answer. When you've done that, call me over. I'll tell you if you're right or not. Then you can start writing it in. And you can even look at the table, there's hints. So like for step 2, I told you what the move was. That we multiplied the top equation by 5. So find the card that looks like they did that. And so forth. Questions on what you're doing? Okay, so you can't move on until you think you have the right order. So call me over when you think they know it. Going from like left to right, like how you read, this is how you would order them. Let me try to make it a bit bigger. All right, next, you are copying it onto your table that's in your notes, the steps. And then you're now putting the move that they made, like in your own words, like what did they do? And why is that still equivalent? So like you could say multiplication, property of equality. Or we can kind of mimic what some of the examples are on the table. Yes? Yes. So we know that all the steps are right now. We filled them in on our table. Now we're kind of verbalizing what's going on. Some were given to you, some were not. So like this was given to you. They multiplied the top equation by 5. Why would that be helpful? What did it do when it did that? They got rid of the fraction. So got rid of fraction. Consider doing that on any situation. Like if you don't want to work with a fraction anymore, what do you have to multiply that fraction by?
Bottom.
The denominator. Good. So if I don't want it to be 4/5 anymore, I multiply it by the denominator. Now it's 4x plus 30y equals 75. So because I did it to one term, I have to do it to them all in order to keep it equal. So that helps us solve. And then also it's still equivalent because we did it to both sides. That's your multiplication property of equality. Now, what did they do going from this step to this step? What's different? They multiplied the bottom equation by 4. All right, that helps us solve because it creates a common coefficient, right? Now I can continue solving by elimination. And then, let's see, what did that last one say? Why is it still equal? Well, you could say the same thing that happened here. This means like the above, basically. It's going to be the same reason. You could also say multiplication property of equality. So that's literally the same thing. You do it to both sides, it doesn't change the solutions. All right, and if you were struggling, well, look, like the top equation didn't change at all. Only the bottom one did. And how can I go from negative x to negative 4x? Well, I can multiply by 4 and then see if they did that to each term. And they did. 18 times 4 is 72. 11 times 4 is 44. So that's what they did. Now, what does it look like they did going from this step to the next step? So top equation is still the same. How did they get this? What would you normally do after you get your common coefficient? You would add the equations together. Because we're solving by elimination, remember? When you solve by elimination, you want to add or subtract them to eliminate one of the variables. Well, since they had it multiplied by 4 on the bottom equation, and these are opposite signs, I would have to add in order to eliminate, right? Sometimes you subtract if they're the same sign, but in this one, we had to add the equations together to create a new equation. All right, so for how that helps us solve, well, eliminates one of the variables, what I would say. And then for why we are allowed to do that, why is it still equal? We saw that in like lesson 14, why it's still equal. It'll still have the same solution, even though it's now a different line. It still goes through the same solution. Make sense? Okay. So then now what did we do when we went from step 3 to step 4? What's the difference here? Well, actually they told you. They divided 102 from each side. So they solved for y. How does that help us solve? Well, now we can substitute the y. Now we can substitute the y into the other equation. And that would help us solve for x. Why we're allowed to do that, there is a property called the substitution property. So that's what I would put. This is prepping you for geometry as well. Lots of proofs in geometry. So yeah, once you know what something equals, you can plug it in. That's the substitution property. And what does it look like happened over here? How did they go from 30y to 35? All right, well, since our next step, since we solved for y, would be to plug it in and simplify. When I plug it in for the y here, I get 30 times 7 over 6, which I know you might not like fractions. You could enter this in your calculator if you want to. It's a fraction in parentheses and you'll be good. But if you do 30 times 7, you get 210. And then if you divide it by 6, you get 35. So this allows us to solve for x in the other equation because there's only one variable. How that lets us do that, I don't really know how to explain. I don't really know how to explain that. I'll just put substitution property again. We're simplifying it. All right, and then bottom equation is staying the same, like we already know what y equals. What did they have to do next in order to keep solving for x? Subtract 35 from each side. Right, they subtract 35 from each side of top equation. How that helps us solve, we're isolating the x. I mean, it's not fully isolated yet, but that's what we're doing. Why it's still equivalent? Well, that would be now your subtraction property of equality, and that's this, but they say it a bit differently. Subtracting the same amount from each side of the equal sign does not change solutions. In other words, that's your subtraction property of equality. All right, what's the last thing they would have to do to get x alone? Divide 4 from each side of the top equation. How that helps us solve, again, I would say because we are isolating x. And that would be what property if you had to divide from each side? The division property of equality. Which, if you wanted to phrase it like it was here, you could say dividing the same amount from each side does not change the solution. So that's, in other words, the division property of equality. Good, any questions? All right, so that now you can eliminate in any situation. How you choose to do that is up to you. Do you want to eliminate the x? Do you want to eliminate the y? Do what you think would be easier, and then you can follow the rest of the steps like how they were yesterday and the day before. But now you're multiplying first to get that complementation. All right, you could work on your practice. Please do not just pack up and like wait for the bell to ring. Open it up. There's only like 6 questions about. Do like 2 of them, 3 of them in class. Reminder, I do have tutoring today, which is unusual because it's a Thursday. So if you're never able to come on Wednesdays, today's the day that I'm here. It'll go back to Wednesday next week. So